Hello everyone, welcome to MathX. I am Dr. Sovan Bera. In this video, we will solve an important CSIR NET July 2026 memory based question in linear algebra. Let's start. If A is an 2 by 2 positive definite matrix, A is an 2 by 2 definite matrix such that trace of a minus 2i equals to 2 and date of a square minus 2i equals to 28. Then the value of date of adjoint of a is what? Since A is positive definite matrix, therefore we consider lambda 1 and lambda 2 be two eigenvalue of the 2 by 2 matrix A. Since A is positive definite, so A is positive definite, therefore these two eigenvalue are strictly positive. That means lambda 1 and lambda 2 greater than 0, strictly positive. Now from condition 1, trace of a minus 2i equals to 2. That is, trace of a minus trace of 2i equals to 2. Therefore, trace of a minus 4 equals 2, because since I is an 2 by 2 identity matrix, therefore trace of 2i equals to 2 plus 2, therefore 4. That's why this is 4. So trace of a equals to 4 plus 2, that means 6. Since trace of a equals to sum of two eigenvalues, therefore their lambda 1 lambda 2 eigenvalue, that is lambda 1 plus lambda 2 equals to 6. Lambda 1 and lambda 2 equals to 6. Now condition 2. Date of a square minus 2i equals to 28. Now eigenvalue of a equals to lambda 1 and lambda 2. A square eigenvalue lambda 1 square lambda 2 and a square minus 2i. Eigenvalue of a square minus 2i, that is lambda 1 square minus 2i and lambda 2 square minus 2i. Therefore, determinant is the product of eigenvalue. We know that determinant of a square minus 2i equals to 28. That is lambda 1 square minus 2i and lambda 2 square minus 2i equals to 28. We know that determinant is the product of the eigenvalue. Therefore, lambda 1 square minus 2i and lambda 2 square minus 2i is the eigenvalue of a square minus 2i matrix. Therefore, we can write lambda 1 square and lambda 2 square minus 2 into lambda 1 square lambda 2 square, that is plus 4 equals to 28. That implies lambda 1 square and lambda 2 square minus 2 into lambda 1 square plus lambda 2 square minus 24 equals to 0. Now we have to find out the value lambda 1 square plus lambda 2 square. 2 square, and that's 6 square lambda 1 plus lambda 2 square minus 2 into lambda 1 lambda 2. That's imply 6 square minus 2 lambda 1 lambda 2. Now we consider lambda 1 and lambda 2 equals to x. We consider lambda 1 lambda 2 equals to x. Therefore, x square minus 2 into 36 minus 2x minus 24 equals to 0, and x square minus 72 plus 4x minus 24 equals to 0. That's imply x square plus 4x minus 96 equals to 0. X plus 12 into x minus 8 equals to 0. That's imply x equals to minus 12 and x equals to 8. H positive definite matrix. So all its eigenvalue must be strictly positive. Therefore, det of A equals to lambda 1 and lambda 2, that is x. That means 8. And we know that for n into n matrix A, det of adjoint of A equals to det of A whole to the power n minus 1. Now substitute n equals to 2. That is det of adjoint of A equals to det of A whole to the power 2 minus 1. That means det of A, that is 8. Therefore, det of A equals to 8, and only B is the correct answer. Now, if you found this video useful, please give it like, comment, and subscribe to my channel MathX for more CSIR NET, GATE, IIT JAM, M.Sc. And thank you for watching. Keep learning and keep practicing. So see you in next video. Goodbye.